Another day, another problem, so let's solve it. Hello everyone, I hope you are all having a good day. Today we're going to solve the jump game problem. This problem can be solved using dynamic programming and also greedy algorithm. So I will show you both solutions. First, let's get started by reading the problem and try to understand it. You are given an integer array, nums, and you are initially positioned at the array's first index. And each element in the array represents your maximum jump length at that position. So return true if you can reach the last index or false otherwise. The first information that we have is that we are starting at the first index of the input array. For example, in this list, we're starting at 3. The second information is that each element in the array represents your maximum jump length at that position. Means that the first value at the first index, which is 3, gonna be the maximum jump that we can reach. Another example for 1, the max jump that we can take is 1 step, means the next position. So for 0, we cannot jump any step because it is 0 step. So basically each number inside the list represents the steps that we can jump. The question is, are we able to reach the end of the list by starting at the first index? For this example, the return gonna be false because we cannot reach the end of the list. Let me show you using this little jumping method. The first index at the list gonna give us 3 steps, so the max reach gonna be at 0, which is index 3. The second number gonna be 2, so the max step that we can jump is 2 steps, so the max reach is 0. The next number is 1, and 1 gonna be the maximum of steps that we can jump, so we reach the next number, which is 0. The next number is 0, and 0 means 0 steps, so we cannot reach the end of the list. After that, we return false. The first solution gonna be using dynamic programming. This technique is used to solve complex problems by breaking them down into smaller subproblems and solving them one at a time. This allows you to avoid having to solve the same problem multiple times. So let's say we have this example. Can we reach the end of this list? So we have 2 at index 0, we have 3 at index 1, and we have 1 at index 2, and we have 1 at index 3, and we have 4 at index 4. Starting at index 0, which have the number 2. So how many steps can we jump? So we can jump 1 step. For that, we're gonna reach the next number. And also we can jump 2 steps, so we're gonna reach the number 1. After that, we move to the next index. The value gonna be 3. So we can jump 3 times. The first jump gonna be the first next number. The 2 steps gonna reach the second number 2, means index 3. And 3 steps gonna be at the last index, mean we reach the end of the list. Then we move to the next number, which is 1. Gonna take 1 step to the next number. Also the next number gonna be taken 1 step. And after that we return true because we reached the end of the list. So to solve this problem using dynamic programming, we're gonna create a status positions arrays that gonna have a list of boolean that have the same length of the input list. And the first value of the status positions array gonna be true since we can always reach the 0 step. And after that we're gonna initialize 2 variables called I and max reach, and we're gonna be starting at index 1 and I gonna be the start index. And after that we start checking if one of this number can reach the last index of the input list, and each time update each position inside the status position array to true if we reach it. If not, we keep it false and we move to the next index until the end. Once we reach the last index 1 time, we can add a break statement, so we don't need to continue because the question is asking us if we can reach the end of the list. After that, we return the last boolean of the status position. If we are reaching the end, it will be true, otherwise it will be false. So the time complexity gonna be O of n squared, and the space complexity is gonna be O of n because we are creating a new array. For the second solution using greedy algorithm, a greedy algorithm is an approach for solving a problem by selecting the best option available at the moment. So for this problem, we're gonna start at the first index, iterate throughout the list, and each time selecting the maximum of length that we can reach. And the most important condition that we're gonna add is if we pass the reach, that means that we have a value equals 0, so we cannot jump anywhere. So the variable I at the end gonna not be equal to the length of nums. For example, for 2, the maximum steps that we can take is 2, so jump 2 steps and we update the max reach to be 2. We move to the next index 1 that have the number 3, so what index we can reach? It's gonna be index 4 because index 1 plus value 3 is gonna be equal to 4, so we update the reach, the maximum reach, and we continue until the variable e it's equal to the length of the list. If it's true, we return true, because if we reach the last index, and for this example we update the maximum reach to be 8 at the end of the iteration, so we're gonna increment the variable I by 1 at the last iteration. So that's why we're gonna have the variable I equal to the length of the list. And that's it, guys. Hope you have understand how to solve this problem if you face this problem during coding interviews. So for the time complexity is going to be O of n because we're iterating throughout the list one time. And for the space complexity is going to be O of 1 because there is no extra space. Thanks for watching. See you in the next video.